Welcome back, ladies and gentlemen. This is Professor Elas. We'll go ahead with chemistry, or let me say mathematics 120. So please make sure that you comment, you like, share, and also make sure that you go back to the videos that I posted about coded geometry. They will help you a lot, and you cannot answer them without, or let me say, I cannot answer geometry questions that I'm trying to answer now without involving those previous videos. So it's quite interesting. If you have not watched, please go back and also watch those videos, like, comment, and share for more videos. So we have got a geometry question here. So the first question is the line joining point P, which is the coordinate of 3, -4, to Q, which is Q, 0, as the gradient of 2. Find the value of Q. So what is this question it's all about? It's finding the value of Q. We have the coordinates, but we are remaining with one coordinates. So it's saying to say the gradient you have been given it is 2. Then we have the coordinates, which is 3, -4. And also we have the coordinates, which is the coordinates for Q, which is Q itself, 0. And hence, labeling or having the hint which is being given the gradient which is equal to 2, that's short to say we have this one, which is x1, y1, x2, y2. Hence, what is the formula for gradient? Is gradient being presented by capital letter M is equal to y2 minus y1 divided by x2 minus x1. So what is our gradient? It is 2. So which is 2, whatever is capital letter M, we replace with 2, is equal to, what is our y2? Our y2 is equal to what? 0. So we put 0 here. Minus what is our y1? Our y1 is what? -4. We know to say negative times negative, that will be what? +4. Then divide by, what is our x2? It is Q itself, which is this one. What is our, we should minus, what is our x1? It is 3. So here put what? With 3. So what's going to happen after do this? We say 2 is equal to 0 plus 4, that is 4, divided by Q minus 3. Hence, this same applies with, I'm going to delight, 4 divided by Q minus 3. Then for stability, I'm going to divide by 1, which is equal to 2 same. Then I cross multiplication here. Then I do this 2 times this one, which is 2. You know what is happening here is equal to 4. Then 2 times Q, that is Q. Note that we're looking for value of Q. 2 times -3, that is -6, is equal to 4. Then we're going to collect the items here, which is 2Q is equal to 4. 1, 6 cross cosine goes outside to be what? Plus 6. Therefore, 2Q is equal to 4 plus 6, that is 10, divided by 2, divided by 2. And what is our Q? Our Q is equal to, what? Is equal to 5. So if you want to prove, to say the answer that you found, you have to make sure that everything you should do, or if you calculate the gradient is giving you, it's the original gradient. What do I mean? I've been provided to say 2, like this. I'm going to delight. Whatever is M, I'm going to put it 2 because it has been given as a gradient, is equal to, I'm going to do like this. Zero plus 4 divided by Q minus 3. So we say 2 is equal to 0 plus 4, so which means the left side should be equal to what? Right hand side. What is our Q? Our Q, not to say it is 5. It will be 5 minus what? Minus 3. Then we say 2 is equal to 0 plus 4, that is 4, divided by 5 minus 3, that is 2. Hence, 2 is equal to what? 2. Hence, that is correct. So that was our first question. Let's try to forge in into another question. Okay. So the question 2 here is saying that the 3 point x, which is 2 comma negative 1, y, 8 comma y, and z, 11 comma 2 are collinear. What does that mean? This means that the line, or they rely, or this, they rely on the what? Same straight line. These coordinates, they rely on the same straight line. Or they are attached to the same straight line. Hence, find the value of what? Y. So what's going to happen here? Same applies with the triangle. Or should I remove that? Same applies. Two coordinates are being attached to one axis. I think I made myself clear. Oh, what does this mean? This same applies, for instance, we're going to have 1 point here, for instance, it is for A, another point here which is for B, another point here which is for C, and are being coordinated in the same what? In the same line. They're still lying on the same line. Same applies now. We're trying to find a certain number here where these lines are being attached, or where this line it is on what point? That's what we're trying to find out here. So what's going to happen here? This was been given to say we have x, which is 2 comma negative 1, and also we have y, which is 8 comma y itself, and also we have z, which is 11 comma 2. Simple. The only key here, if you're able to remember the formula for gradient 1, good. So what's going to happen? We're going to squeeze this one. Since they are collinear, they're relying on the same line, we're going to use x, 2 comma neg 1, and z, which is 11 comma 2, and put this one as in x1, y1, x2, y2. So that means to say, if you use the formula for gradient, we're going to replace based on what we've been given there, using x and z. What is our y2? Our y2, it is what? It is 2 itself, which is 2 minus. What is our y1? It is negative 1. That means to say, negative times negative, that is what? Positive what? Positive 1. Divide by. What is our x2? Our x2, it is what? 11. Minus. What is our x1? It is 2. So that means to say we're going to have 2 plus 1, that is 3, divided by 11 minus 2, that is 9. Hence, our gradient is equal to what? 1 over 3. Positive 1 over what? 3. This is our gradient, isn't it? Good. Then, if you try to go back, you can use y and z, x and y, since they are collinear. So what's going to happen? We're going to say x, 2 comma neg 1, y, 8 comma y. Like what I said, we can use x and y or z and y since they're collinear. Using the same gradient that have been found, or any sort that have been provided, the same one that we're trying to find here, you're going to have 1 comma 3 is equal to y2 minus y1 divided by x2 minus x1. So that means to say this is our x1, this is our y2. I mean y1. This is our x2, this is our y2. So that means to say y1 minus divided by 3 is equal to, what is our y1? Our y2, it is y itself, minus what is our y1? It is negative 1. So which we say negative times negative, that is positive 1, divided by, what is our x2? What is our x2? Our x2 is what? 8. So you say 8 minus, what is our x1? It is 2. So hence we're going to have 1 divided by 3 is equal to y plus what? 1 divided by 6. Should I take this one here? We're going to have 1 over 3. 1 over 3 is equal to, just trying to relate here, divided by 6. Hence, we cross the multiplication there. That means to say we're multiplying 3 times y plus 1 is equal to 6. So 3 times y, that is 3y. 3 times 1, that is positive 3, is equal to 6. Then correct the right terms, we're going to have 3y is equal to 6. When 3 comes equal side this side, it will be what? Negative 3 since it is positive. Then I'm going to have 3y is equal to 6 minus 3, that is 3, divided by 3, divided by 3, and their answer it will be what? It will be our 1. So this shows to say, where this line is passing on 1. That's where these coordinates that are collinear. So I think this question, our discussion was perfect. Please don't forget to like, comment, and share for the purpose. Don't forget also to subscribe for more videos, please. This is Professor Elias. Let's try to explore the next question, which is question 4. Thank you.